So we're looking at the Danish FP9 maths exam, December 2022. And this video is all about question 3, ski run. It says Sophia is on a ski holiday. The sketch shows a cross section of a piste or a slope that she's, let's say, skiing on. The slope has a constant gradient. Then you've got the height of the slope, the length of the slope, and the gradient of the slope, and different measurements, and they all form a right-angled triangle. So this question could be about Pythagoras or trigonometry, but let's have a look. 3.1, draw the cross-section in a ratio that you choose yourself. You don't need to write what ratio you are using. And then, well, that's 3.1, so let's draw that. And it's quite easy for us to do because everything's at right angles. It's a right angled triangle, and the squares we're going to draw on have right angled grids on them. So let's go for red here. So all we've really got to do is draw or measure the 56 meters and the 396 meters in an appropriate ratio, and then the 400 will just come out to be right. So we don't need to really worry about the 400 because we've got the right angle there, and the squares on the grid will already be at right angles. So let's just get rid of that and get my white answer paper and my yellow rough paper. So looking at the number of squares that I can get across the page, well, 396 meters across. I can't quite divide it by 10. I don't think I've got 39.6 squares across there to fit it in. So I think I'll just divide everything by 20. So let's just put the question that I'm on, 3.1. So 396 divided by 20 is, let's try and do that in my head, 198. No, sorry, 19.8. And 56 divided by 20 is 2.8. So if I draw the thing so that it's 19.8 squares across and 2.8 squares high, then everything will be in the right ratio. So I've done this sketch. I made it 2.8 squares high, as I calculated, and that represents 56 meters. I made it 19.8 squares long, and that corresponds to 396 meters. And crucially, I've labelled it with the real life measurements, not with the diagram measurements. It's not really of any use to anyone to know what it is on the diagram. It's representing something in real life. So it is, as I mentioned before, in the ratio 1 to 20, so the scale is 1 to 20. But as it also says in the question, don't need to write that, so I won't. So I've labelled all of the real life measurements, and of course it looks nothing like the original diagram on the question paper. But that question on the question paper is, or that diagram on the question paper is labelled as a sketch. So it's not meant to be in the correct ratio. It just represents the situation. So you often see that on exam papers. On an English paper that would say diagrams not drawn to scale. And it's just so that you don't get the answer from directly measuring the diagram on the question paper. So it represents the situation broadly without giving you something you can get the answers from. And as you can see, that angle there, well, if you were to measure that, that's not really 8%, 8 degrees on the diagram. That looks to me a lot more like maybe 20 degrees. So it says Sophia tries another slope which also has a constant gradient. The length of this slope is 1,200 meters approximately. So when they're talking about the length of the slope, here on the original diagram you can see they're talking about the actual surface that she's going to ski on. So it's the hypotenuse of the triangle, in other words. So that's the bit that's going to be 1,200. And as you can see, 1,200 is 3 times the original 400 that she skis on. So the question is, explain why the height of this slope, so that's that bit, is 3 times as much as the height of the slope on the sketch. So I've written, if you can read this, it's quite small, explanation. The cross sections of the 2 pistes or slopes are linear, mathematically similar. The scale or the ratio between the 2 triangles is 1,200 to 400, which is the same as 3 to 1. So the height is therefore 3 times 56, 3 times as big, which is 168. So that's more explanation than I needed to give, really. The key thing in the question was explain why it's 3 times as big, and that's because you're getting 3 from 1,200 divided by 400. I guess on the original sketch I should have labelled the 8 degrees, so I think I'll just do that now. Let's avoid red because that's the teacher colour. So 8 degrees there. There we go. Question 3.3 says slopes that have a gradient of 8 to 15 degrees are called blue slopes. Sophia's mother claims that such a gradient corresponds to an average slope of 15% to 25%. So average slope or average decrease perhaps. And they've given you a nice little formula there. Average decrease is H divided by A, which also I notice in trigonometry is the tan of the angle, the opposite over the adjacent. So that's going to be useful. So I've drawn very bad sketches of the 2 extreme cases here, the 8-degree triangle and the 15-degree triangle. So they've both got a height of H in each case, and then the bottom of the triangle is A. And in trigonometry, that's the opposite side, which is modstående in Danish, and then the adjacent side, which is hosliggende in Danish. And in trigonometry, when we've got the opposite and adjacent sides, then we're using the tan of the angle. So tan of 8 degrees in the first case is the opposite over the adjacent, H over A, and that's the thing that's been called the average slope, Gennemsnitsfelt, in the question. So that's the, I'll just abbreviate that to Genfeld, which is, yeah. And then in the 15-degree triangle, the average slope is h over a, which is the tan of 15. And those are both things we can work out on the calculator. So over to my calculator. So the tan of 8, making sure I'm in degree mode, is about 0.14. And that's the same as 14 hundredths, which is the same as 14%. And then in the 15-degree triangle, the tan of 15 is about 0.268. And 0.268 is the same as 26.8%, because percent just means out of 100. So just looking at the original question, the question says Sophia's Moore claims that these slopes correspond to an average slope, Genomsnittlichfeld, of 15% to 25%. So she's claimed 15% to 25%, and we've calculated 14% to 26.8%. So she's sort of in the right ballpark, but our answer to this question really wants to show this whole calculation leading to the 14% and the 26.8%, and then a comment relating that to her claim. So I've written that for the 8-degree triangle, the average slope is, so that it was the tan of 8, and then times 100 to make it a percent. So I've put the percent sign there, and that was 14%. And then for the 15-degree triangle, I've written that the average slope is 100 times tan of 15, and that's how we got 26.8%. And then I've just put a comment, she's nearly correct. So I've tidied that up a bit, kind of lined up my units there and lined up my decimals there, and then got all the single units, the tens, the hundreds lined up down the page. So doing this on an iPad, it's a little bit of a luxury that I've got that's maybe harder to do with physical paper. I've underlined all my answers neatly, so hopefully the order of that is fairly good. All the calculations aligned at the left, all the explanations lined up at the left, all the colons lined up. Whoops. So I'm happy with that. Except, of course, for the fact that I've noticed just at the end here that I've labelled it all as question 2 when it is in fact question 3. So let's just fix that. Delete that and stick some 3s in there. There we go.